My name is Jenny Gurney again. I'm here today to sort of take off where Chip left off. He was talking in general terms about operating a large XNAT, and I'm going to talk more specifically about the CNDA and our environment and some things we've gone through, the different data flows within our environment, and then some issues we've experienced in database queries and some things we've tried to do to tackle that. So I've been working for the CNDA for 7 years now. I was essentially brought in to provide the XNAT developers some relief because they were doing double duty as CNDA help desk and trying to get another release of XNAT out all the time, and it was becoming clear that that was not going to be possible anymore. They needed to focus on the XNAT. So back then it was Tim and Mohana and Kevin Archie and Misha and me, pretty much, I think. So that's when we really started up sort of a CNDA help desk. Quickly, Lauren Wallace came along to help. She's mostly a developer, but she helped run the help desk too. And then before she went on to run the DCA, which was the Diane TU's XNAT. And then about 3 years ago, Jeanette Klein came along, and she runs the help desk really today. She pretty much does most of the work. I'm there too, but she's doing most of the work. We established email and a ticketing system. We used to use something called FogBugs. Now we use something called Jira Service Desk. Oh, and I should say, is Jeanette in the room today? No, she's probably back doing work. Excellent. And that's what we do for help desk now. So the CNDA environment, this is the same slide that Dan obviously showed you earlier. And I'm just going to talk about the different pieces and walk through how everything operates together. First, we've got the CNDA production web server. Currently, we're running on CentOS 6.7. We're running on Java 6, Oracle Java 6. We tried to go to OpenJDK 8 and had some issues, but I think those have actually been resolved from what I see in 1.7. So when we go over, we'll definitely be going to Java 8. We're currently running on XNAT 1.6.5. We have about 40 modules that we're running on top of our XNAT, and those are available in a public Bitbucket repository that was actually on the last slide, if anyone's interested. We've contributed a number of those back to the XNAT marketplace, including some radiology reads, some uniform data set, assessors, NIH stroke scale, some psychometric assessors. There's a number of them. We also have a very naughty sort of just clump of customizations that we pour over the XNAT install as we're doing our build process. So it's going to be an interesting time migrating for us to 1.7 and making all this stuff into plugins. We've got a lot of work ahead of us. CNDA users. We, I think, are a GUI heavy XNAT. We have a lot of users. We have 350 users enabled as of a few days ago, and we disable after 6 months of inactivity. So our UI gets pounded really hard, and we tend to be the people making a lot of requests to XNAT for GUI customizations, and also just using those tools a lot. We do a lot of uploading and downloading from there. We also, of course, our REST API gets used a lot. A lot of our users write scripts against that. And then, and this is actually not technically, the slide showed us coming in, our users coming in over HTTPS. And so this is technically incorrect, but otherwise we would have glommed up our nice diagram. So, but I'm going to throw it in here. We also have users coming in on a project. They do syringomyelia, anyone? Research Consortium. At any rate, they're uploading clinical data, essentially, head and neck scans from 35 different sites. So that's a lot of different scanners with a lot of different PHI to strip. And so we ended up using something called CTP client. I'm going to talk about CTP a little bit more in a minute. But we're using the CTP client, which is very similar to Upload or Applet, except for it had a couple more anonymization features. And they are also uploading. It comes in as DICOM to us. They send it through CTP clients into a CTP, and then it comes in as DICOM to us. So all these users are hitting our XNAT a lot of the time. Next, our Postgres database. We're running Postgres version 9.4. And we found, just from watching our usage, that we really can cache about everything. Our Postgres database can cache about everything that we're asked to cache. And that actually affects how we manage our Postgres. So when we find that queries are getting slow, it's generally not a question of resources for us. A lot of times that's why we turn to things like indexing, which I will talk about more in a minute. Next is our file system, which Chip has really talked about a lot, so I won't talk about it much. But I am really excited about the thing he mentioned in ZFS, and it's also part of the practical today, where we're going to take every one of our projects and put it on a separate ZFS mount. And I think he talked about this a little bit, but I'm just going to describe it one more time because I'm not sure if it was described in quite this way. But essentially what happens is, we have data going back to 2004. Some of these projects are very old. Nobody touches them anymore, but we're not going to go delete the data. So we have other options. We have now in our environment, we have a cold data storage option, and we'd love to be able, it's a lot cheaper than the live backed up data storage option, and so we'd like to be able to just take these projects, pick them up and move them away. And we asked Chip if we can do this, and he says, well, you can, but then all of your snapshots will be, destroyed. We'll have to, the snapshots will no longer be any good. So the point of doing this ZFS mount for every project is really so that to have these movable parts with all these different projects, so you can just pick up a project and put it in cold storage or delete it if someone just says, forget it, I don't want that data there anymore. A lot of times with bold processing, if bold processing goes awry and it gets snapshotted, that's huge results that we also can't delete because of the snapshots as well. So that's what Chip was talking about there, but I won't linger on that for too long.
Sorry, quick question.
Yes, of course.
The main point of having the daily snapshots is
What is the point of it? In case something goes wrong and we need to revert to an earlier snapshot.
Has that ever happened?
Yes.
Oh, yeah.
Or people will just, people have just deleted a session. Oops! Oh my God, my data. And then we go back, we can look and it's mounted, he has the snapshots mounted, and we can just go drill in there, look on any day where we know it probably was, and pull it back and we usually send it back to the DICOM receiver and it's back, and they think we're miracle workers. It's really all Chip. Most of the magic we do is him.
Had times where it was discovered months later that something was accidentally deleted, and we still have that.
Yeah. It is very useful. So we don't want to give up our snapshots. We are always debating how many, back to what period to keep them, because that's taken up a lot of room on our system, and now that we have to pay for it quarterly.
Forever is always awesome.
Yeah, right. The forever option was never forever. We just ignored the fact that disks die, and you pay a certain amount of money once, but it's not really forever.
So how far back did you go with your snapshot?
2013? Is that?
October 2013 is when the CNDA snapshots began, and they're daily since then.
So if something got lost before then, it's, yeah. We had snapshots before that, but we don't have those anymore from the Blue Arc. Yeah. So I was just going to talk a little bit about our processing cluster. Chip talked a lot about it already. We have a lot of, the standard tools installed there, FSL, MATLAB, FreeSurfer, some bold processing we develop here called 40FP. Not only can we use this processing cluster for the CNDA, but also other users are allowed to log in and use our processing cluster, and this other XNAT Dan mentioned today called TIP, they're allowed to use it. So it becomes kind of an interesting management process, trying to determine who gets what resources. And so we have to play games with queuing to make sure that TIP gets FreeSurfer space when they need it. It's been interesting. So now I'm going to talk about sort of the different data flows from scanners on our campus. You can see here we have shadow servers receiving all the data from our scanner facilities, and we actually have a CTP again in the middle of each of these relays. So I'm just going to break to talk about CTP for a second. I noticed yesterday that we have a number of CTP users already in this room, and I'm not going to get deep into it. We have a practical on CTP. It may not be ready by the end of the day today. It will be ready within the next day or so. But it will be on the day 2 practical sheet eventually. And it will have a lot more information about CTP, but essentially the parts of CTP that we use are sort of building up the different stages of DICOM processing. You can do many different things, many things that XNAT can do as well, like anonymization, series import filtering, like we talked about yesterday in XNAT. You can see down here, peeking out at the bottom, DICOM decompression. DICOM, the image can come in different formats, and if you have a particular jar installed, CTP does a very nice job of decompressing your DICOM. This tool can be configured in a lot of different ways to serve a lot of different purposes, as we'll see. So we have a couple different scan facilities on our campus. We receive all the research data that gets scanned on the WashU BJC campus comes to the CNDA automatically. One of our facilities is a clinical research scan facility, so that means that we have people who get paid to just be technicians, but the facility is somewhat rigid in procedure, so you can't just, sometimes people come up with sort of new processing boxes that they want to throw into the scanner room to get the data directly off the scanner, and you can't do that at this facility because there's clinical data involved. It also means we can't do an auto send from the scanner because we don't want to get the clinical data that they acquire, so the technicians have to manually send us every DICOM session from the scan facility. But it does mean that because they're fairly organized, when they store their protocols in the system, they store them in a way that records what will ultimately be their project ID in CNDA, so that's nice. We have a reliable source of that routing information that we talked about yesterday coming from the scan facility. And we also, so the facility is called the CCIR, and a few years ago, what they used to do is they would just back up everything and keep it on CDs forever. But that was becoming difficult, and sometimes people would come in and borrow the books of CDs and then not give them back. So a few years ago, they asked us, will you be our archive? And we said, yes, we would like to do that. Also, just because, once they were already sending everything to the CNDA, but the investigators who received their data were under the impression that they could do whatever they wanted with it when they had it on CNDA, when they would do nasty things like rename it or put it in a project that CCIR didn't expect to find it in. And so they wanted their own pure, clean archive as scanned so that they could find their stuff. So this is one instance in which we used CTP, and we just use it as a fork, essentially. We send the scanner technicians, as I mentioned, they have a node on their scan facility at their scanner, and they push a button and send it to CNDA, which really goes to a CTP. And that forks the data and sends it both to an investigator copy of the project and to a CCIR copy of the project. And the way that we do that is we have two DICOM receivers that we're using on CNDA. One is the standard out-of-the-box XNAT DICOM receiver, and that's the investigator copy. And then we have, there's basically a Java class you can write to change the routing underneath in XNAT. And we use a separate, this other DICOM receiver to glean the protocol and make that into the subject in XNAT. And we take the subject, the date of the scan and the time, and we make that the session label and stick that away in the CCIR archive through this other DICOM receiver. And then the other thing that we do for the CCIR, which is something that David Cash mentioned yesterday in his talk, is we also have a Siemens PETMR scanner. And so we have something called list mode data, which needs attenuation correction. And so we have a little bit of a different solution, and I think it's a little more sneakernet than what he mentioned, but it's for human process, the scanner techs actually prefer it. So they were in the habit of saving all their stuff to a USB drive just in case. All the list mode data, especially since that doesn't go to CNDA automatically. And so they would have these things on the USB. We tried doing some exports to the network, but the network over there, unless they change the bandwidth, is far too slow to actually export data in list mode onto their network. It takes all day and keeps them from being able to get to their next scan. So we derived this little system where we took one of these mini PCs that Chip was referring to, which is called a Nook device, and we just put some scripts on there and we let it sit over in the scanner technician's office. And at the end of the day, they go and they take their backups, which they're making anyway, and it has several USB ports and just an SSD, so it's real fast. and they plug it in, and it every night it looks for the MR sessions to see whether they're on CNDA already, and then it goes and it matches up the list mode data by study instance UID and attaches it to an MR session there. So it's been working out pretty well. From that point on, the imaging core, who is reprocessing all this data, downloads it via a script and uses something called Siemens E7 tools. Also, I believe this whole process is automated now to reconstruct the data, and then they upload the new series back into CNDA, and it's all a nice automated process from there. The second scan facility that we have is actually in the building where we work, and it's a research-only scan facility, so it's a lot more loosey-goosey. You can get them to stick stuff in the scanner room if you want to. The researchers and their teams are often the ones running the scanner, but that means there's a lot more variability in naming conventions and things like that. You're not going to get them to name things properly. But they do have a system down there where they have to log in to just record who's using the scanner. And so we were able to hook into that. We call it the Research Imaging Information System is their name, but I believe it's just an in-house piece of software. So we went to their developers and said, is there something you can do to help us route? We want to auto send these things from Bay 3 because Bay 3 is the name of one of our bays. We want to be able to do auto send because there's no way with all these researchers and teams that they're all going to just go and click send every time they do a session. But the MR facility would really like it if we would collect all the data. And so she was able to build in just some simple REST calls to CNDA, one just to tell us that initially when they log in and create a protocol in their software, we get a REST call that just says, okay, there's a new project. And she just uses the create new project REST to go and do that in CNDA. And then when they ultimately go and do a scan and log in, we get a little signal that says, this protocol has just logged in. And that lets us know that all the auto sends that will subsequently be coming in should be routed to this project. That also requires another DICOM receiver. So we have another flavor of DICOM receiver for that handles these messages from the RISC system to say, okay, I have a login. Know that if auto send comes in on this receiver, route it here. And for the most part, it works pretty well. The CTP is not doing a lot of work. We have one in the middle of this process as well, so that the data that's getting auto sent is coming through a CTP. We use it as a buffer, partially just if I need to take down the shadow server that's behind it, then it's really nice to be able to just have the CTP, it will queue the data for me while the CNDA is down, and then when I bring it back up, it'll start sending it again. And then also, if anything ever happens, I keep about a 30-day, there's a file storage stage in CTP, and I keep about a 30-day backup there just in case something happens to the data in the meantime. So that's very useful. And the Chip mentioned the shadows. I think we've all mentioned the shadow servers a lot, so I won't linger on that. But they are very useful to a point. We use them almost entirely for receiving DICOM traffic because until very recently there were a few conflicts that would keep them from serving other purposes. All those have been resolved, and those were sort of the last blockers to load balancing as well, which we're very excited about implementing. Another thing we do is retrieve data from the hospital PACS. That's the clinical imaging storage system. So the reasons that researchers might want to pull data back from the PACS are retrospective studies. They've applied to the IRB to do a study on pre-existing clinical data, or sometimes they just have subjects who are in a research study, but they know they have some extra CTs over at the hospital and they just want to get everything together. So right now, the way that we do this is we have a tool we've written in Perl, and it does DCMTK queries and retrieves, essentially. What we do is we have a template, and we give that template to the researcher, and they fill it out. And they give some search information for the PACS, so either an accession number or a name and a date. We have different variations you can put in. And then recoding information, right? So we need to know your XNAT project. We need to know what you want this subject to be called when it comes into us, and what you want the session to be called. And then every night between 7 and 11:30, because that is when we are allowed to do this against the PACs, otherwise they get mad at us, we turn this thing on and it will just recurse through our spreadsheet, make these queries to the PACs. If it gets anything back, it will actually, if you're familiar with CTP, there's a remapping feature in a file called lookup.properties, and it will take that recoding or remapping information, put it in the lookup.properties, and then it will do the CMove, and it'll send it over to the CTP, where the data gets recoded and de-identified to a point with, sort of a limited PHI data set. We leave in dates. We don't change the study instance UID. And then, I take that back. We do change the study instance UID in this case, yes. And it forwards it on to CNDA via a DICOM transfer. So the next thing I'd like to talk about is data feeds from studies that we work with. The first one is called Diane. I think David mentioned it, it's been mentioned a lot. It stands for the Dominantly Inherited Alzheimer Network. We're in about the 7th year of a 5-year grant. It got renewed, so we're going to be at 10 years. We started out with 10 sites, and now in year 7 we have 22 sites collecting data on 5 continents. The former PI of the study, Dr. John Morris, who's also the head of our Alzheimer's Center and is an amazing researcher, went out and was always recruiting these new sites, and to his staff it became a joke that you need to be very careful whether you invite Dr. John Morris to your backyard barbecue, because you might indeed become a Diane collection site. So Diane collects many of the same things as the GenFi study that David mentioned yesterday. We have clinical data, psych data, tissue in the form of biomarkers and genetics in the form of tissue, and imaging. The only things that get uploaded directly to the CNDA are imaging, and which we do through the uploader applet, and then we also upload ePrime, which is a format for psych data. It's a proprietary tool. We have a nice little uploader that Lauren Wallace wrote for us, which will extract out the ePrime text files and generate a XNAT XML. So the rest of the data gets uploaded by the coordinators into a repository, which you may have heard of, called the ADCS at UCSD. And we have a Java tool, essentially, that uses HTTPS to just pull over CSV files from them about every 4 hours. And we transform those CSV files into XML and push those into our repository. We also receive a push from the Mayo Clinic. They do our MRQC, and they have a Groovy tool we wrote for them, and they push data every night so that we have our QC for Diane in the morning. And then the other task that we do for Diane is something called the data freeze. It's been annual, and then it's been semi-annual. We're going back to annual, thank goodness. So in this process, essentially, we have all of these. We talked about that umbrella scenario yesterday. Diane is essentially an umbrella. We have a lot of collection sites. So what we do for the data freeze is we create one giant project, and we recode everybody in Diane. Diane is kind of a very touchy project, because these people have been diagnosed or are likely to have early onset Alzheimer's, and it's a very small group of people, and they're always very worried that someone will figure out who they are. So we recode them with another identifier and put them in another project where they are all together, and then about every year we look at every QC measure on every single piece of data collected, put spreadsheets together for everything that's past QC, and send that off to our biostatistics core. And then we also take all the imaging data and make it available in this one big project, or under that data freeze for everything that's been released for that data freeze. Yes?
Are you guys planning on rolling out the Java application to those sites? Have you had any feedback from if they can install it on their servers?
We are planning it. It is something that we're working through right now. We're doing a pilot with basically our Diane coordinator here. And we We hope there won't be a problem, but we realize because you actually have to install an application that it is a complicated process. So we have at least until September, so we're hopeful that we should be able to work out all the kinks before we actually lose functionality. But yes, it has been in our thoughts. We have manuals written. If anybody wants to borrow it, we have one that we've been passing around for the various groups who use our uploaders. I'm happy to make that available if any of you use the uploader applet and need manual changes for the uploader application. We have another project. This is a far simpler project called MEDEX. And they are based at UCSD as well, just coincidentally, but not related at all to the ADCS. It stands for Mindfulness, Health, Education, and Exercise, which is almost the biggest stretch in an acronym I think I have ever seen. They were really trying hard. We're in our second year of a 5-year grant, and I believe they're going to have 450 participants between our two sites, WashU and UCSD. So I'm going to bring up the little mini computer CTP that we've discussed before. We have a CTP installed to facilitate. We only collect imaging for this study. Everything else goes into REDCap, which you may have heard of, which is great. That is fine with us. We're happy to just do the imaging. So we have this little mini PC Nook installed with CTP at UCSD, and this is probably one of the most useful scenarios that we have for CTP, which is that this device sits there near their scanner on the network where the scanner can see it, and they will set the CTP receiver up as a node at the scanner. That allows them at UCSD, when they do a scan, to just click send. It goes to our little box, but of course, as we talked about yesterday, DICOM is not a network secure protocol, so it's then from CTP, it gets packaged up and sent off as HTTPS over the internet to CNDA. After that, there's an interesting process we go through. There's something called multi-echo bold, which is becoming more prevalent, and we have to extract out the GE multi-echo bold into four echoes bold, and we have to extract out those using a cron job once we receive the data every night, which I'm excited about the event triggers because I'm hoping that can be one every time we receive one of those. And so we had been working with John Perry, who's the developer of RSNA's CTP. And we were initially, when we used to try and do this at volume, and these GE sessions, the multi-echoes are huge, like 60, 70,000 files. What's that? Oh, I'm sorry. RSNA is the Radiological Society of North America. They have a conference every year. All the radiologists go. We were having issues because initially he had an HTTP send, but what it was doing is it was sending out each individual file to the XNAT, which was fine via REST, and it was fine, it worked, but every single time that happened, every time you log on to an XNAT, it creates something called a session, which is like a little thing in memory that says, you're logged in and maybe some other stuff about your login. And every time the REST call got issued, another session got created. And this is a really good way to shut down your XNAT when you have 70,000 sessions getting created in succession. So we worked with him, and he actually put in some support for XNAT directly into CTP for the HTTP export so that you can actually use this. It's documented. I have the link down here. For how to use that, but so that he will attempt to use the J session and then reuse the J session. It does a zip export to the DICOM zip importer on XNAT. And it works pretty well, and it improved our performance vastly. So the next topic I wanted to talk about was continuous integration, and I'm only going to talk about it for a second, but it's something that we're really excited about. So this is more just software development-y than XNAT. So continuous integration, just for anyone who might not be familiar with the term, is basically the idea that every time a change gets checked in to your code, that you should trigger processes to go rebuild everything and then test it. And that is awesome, but that is not exactly what we do, because in CNDA, what we really need to test, XNAT is actually doing maybe closer to continuous integration, or I think they're trying to get there. So they're doing all the base XNAT stuff. We don't need to retest that. But what we really want to test are our pipelines. Those are our big customizations that we rely on. But you cannot go test free server every time a change gets checked in somewhere, so because it takes 12 to 13 hours to run on our cluster. So we do it once a day, but we call it continuous integration because it's close enough. So what we do is every day, Chip generates one of those wonderful new virtual machines that has a copy of yesterday's data on it. And as soon as his Puppet process finishes doing that build, it triggers a Jenkins, used to be Hudson. This is just a scheduler task, and which runs a build of basically everything that has been checked in up to the dev tip of every repository we have, and deploys it on that dev server. And then once that's done, it triggers a Jenkins task to run some automated Selenium pipeline tests. Charlie Moore, who has been working in our lab for the last 3 years as a student and just hired on as our QA lead, is actually going to do a presentation this afternoon to tell you more about these tests and this process in our lab. So that's Charlie over there. So I'm very excited about this. It means quicker deploys and being able to be sure that nothing broke the last time that we made a change. Finally, Chip mentioned that we've been having some database issues. And the funny thing is that, like I said, when we look at look at our resources on the database server, we're not having memory issues. The only thing that we're really waiting on sometimes is file system resources, and that's where load balancing hopefully will help us out. But some of the queries themselves were just taking inordinate amounts of time. So some of the places we would find them were in a listing. If you click on your project and go to MR sessions, that listing would take a very long time to come up. Or it wouldn't just never return, or at least to the user, it would never return, or they'd get logged out. Also, we experienced that, and we also experienced just things slowing down in general. And so the first thing that we try and do to help this is identify slow queries or tables. But how? So the first thing we do is we go to the Postgres logs. They don't by default log every single query, so there's some configuration you can do. In the postgres.conf file, I think on Vagrant it's here, I looked it up, to change how long you want the query to last before you log it there on Postgres. So that's one way to figure out what's taking so long. XNAT has an SQL.log in its logs. It by default is not turned on to log everything either, because it really slows you down if you turn it on. So you don't want to do this in production either way, probably, but on a dev server, it's a good place to do it. You can turn it on. In Log4j, you would have to explode that root war. You'd basically be doing development at that point anyway, and you can stick the Log4j properties in that exploded root war there. And then I just threw in what the Log4j settings would be. I won't make you endure that. And then the other thing we did to find sort of issues is if things would be very, very slow to the point of halting, and we'd go over and look at the resources. Now how you look at the resources depends on what operating system you're running. We run Linux, so we run top. And we could see that there were 5 processes that had been running for 2 hours, and they were each taking, or maybe not 5 because we really would have shut down then, but they were 3, and they were all taking 100% of their CPU, and I think there are 4 CPUs on our Postgres server. So and that's a good way to find them as well. So we can go look up the process IDs are in there when you do that, and you can go look up the processes and figure out where they were launched. If you have multiple servers like we do, then it's helpful to go find out where they got launched. So once you've identified, and another way you can identify the tables or the processes are through monitoring tools, like New Relic is the one we use. And this slide makes me cringe a little bit. And I think Dan has offered actually to buy a license and share it around to various XNATs of this monitoring tool. It's really helped us in database tuning recently. As you can see, it shows you sort of the tables, and these probably, if you're familiar with XNAT data types or tables, this looks familiar. These names. It shows you where you're spending your time. This would be that QC uploader I mentioned from the Mayo Clinic, and I got to look at that because I have no idea why it's driving it up, but that's when that, I can tell from the access logs, that's what was coming in there. I'm not sure why that was so high. So anyway, this has helped us identify some tables and some queries. It'll go down. If you click on each of these, it'll show you sort of the longest running queries, and that's real helpful. And so then what can you do? You've identified your tables or your queries, and for us it's just simple database indexing, finding columns that are in wheres or joins in those queries and indexing them. We've been doing some work there with some indexes that weren't originally in XNAT. I just stuck them all on the page. They may not all be for you. There's not that many, so I don't think there's a ton of overhead in them. You can also poke at Postgres tuning as we have. It's so specific to your setup of Postgres that I'm not going to recommend any parameters. That's what the parameters are there for, so I don't know how helpful it is, but that is something you can do. And then, of course, the PG admin tool that was mentioned when we talked about installing Postgres is a great way to visualize everything on your Postgres database, and I recommend it wholeheartedly to use that PG admin tool. And you can use something called explain, analyze to actually go look at how this whole query is being built. And when you put an index in there, here, oh, I thought I had a slide. I'm sorry. There's some, okay, I don't know where it is. When you put an index in there, it'll show you how the picture will change, the whole map will change, and you'll see the index going. And it'll also show you an expected time for the query to run, but sometimes that's right, and sometimes that's not. So, were there? That is all I had. Are there any other questions? Okay. Thank you.